Here's another example. We're going to graph the inequality negative x over 4 minus y over 3 is greater than 1. It's a linear inequality in two variables. So step one is always graph the line. Remember the straight line. So graph the line, and in this case the line is negative x over 4 minus y over 3 equals 1. That's what a straight line equation looks like. Now, if it's easy to find the intercepts and the intercepts are not fractions, then it's convenient to use intercept. So for the x-intercept, I'm going to substitute y equals 0. So negative x over 4 plus 0, because that becomes a 0, equals 1. I'm going to multiply both sides by negative 4. So that way I cancel the negative sign and the 4. So the negative times negative is positive. So I get x equals negative 4. So negative 4, 0 is the x-intercept. Let me mark this. So that's negative 4. So negative 4, 0 is this point. Now let's find the y-intercept. For the y-intercept that lies on the y-axis, any point on the y-axis, the x equals 0. So plug in the x equals 0, so you get 0 minus y over 3. You're plugging it into this equation of the line equals 1. I multiply both sides by negative 3. Cancel the 3's and cancel the negative sign, so you get y equals negative 3. So that's 1, 2, and that's negative 3. So these are the intercepts, the x-intercept and the y-intercept. And we're going to join the two with a straight line. So since we are looking at a strict inequality, we could, let's just draw a solid line first and then make it a dotted line. So that's the equation of, or rather the graph of the line. And now the graph, remember, separates the plane, the entire xy plane, which goes on and on forever, into two regions. That's your first region and that's your second region. And remember, the solution to the inequality, and this comes to the second step, step 2, is figuring out which region is the solution set for this particular inequality. So negative x over 4 minus y over 3 is greater than 1. The origin is always an easy point to plug in. So take a sample point, and in this case 0, 0 is an easy point to plug in. You can plug in any point, but why not plug in an easy point? So that 0 is greater than 1. We know this is not true. This is not a true statement. So the region containing the 0, 0 is not to be shaded. It's the opposite side, because one sample point, one sample from region 1 is enough to tell us that none of these points will satisfy the inequality. So we know that it would have to be on the opposite side, which is region 2, that gives us the solution. Now right now we have a solid line, so this is the solution set for negative x over 4 minus y over 3 is greater than or equal to 1. If you make that a dotted line, then we get what we need. So we shade everything. It depends on how much of the graph you show. Remember that the graph continues even though we are not able to show it on this limited space. Okay, so let's make this a dotted line since we're trying to figure out. So make it a dotted line. So this green area, every single point, infinitely many points in the green area satisfy the inequality. And what is the inequality? The negative x over 4 minus y over 3 is greater than 1. So plug in any point xy in the green area and it's going to satisfy this inequality. So it's called the solution for the inequality, and what we've done is graphed the inequality. Now I'm going to show you 2 more examples. Let's think about, let me see if I can erase this without. Okay, so I'm going to find the solution to the inequalities, and I'm going to write down my examples here. Let's say here. X equals 4. We know that this is a straight line, and every point on this straight line will have the x coordinate equal to 4. So let's 1, 2, 3, 4. If I draw this line, that's the line x equals 4. Remember that it is a vertical line because every point on this line, remember that the y is changing but the x remains to be equal to 4. If you think of any point on this orange line, the coordinates, let's say we're looking at this point. This is 4, 1. This is 5, 1. The x is always, 4, 2. Sorry about that. 4, 2. The x always remains 4. Think of this point. It's 4, 0. Think of any point on this line. The x coordinate is always going to be 4. And that's the equation of the line x equals 4. Now, if you're trying to solve the inequality, this orange line divides the plane into 2 regions, the region on the right and the region on the left. And the line x equals 4 forms the boundary of the 2 regions. Now, if you're trying to solve the inequality, let's say x greater than or equal to 4. Step 1 is graph the line, and we've graphed the orange line. X equals 4. It's a solid line because of the inequality that is not a strict inequality. It's greater than or equal to. That's why we have a solid line. Now we have to pick which region. Is it 1 or is it 2 to shade? So pick an easy point, 0, 0, which lies in the second region. In the region 2, we are picking this point, plugging in the values of x and y. There is no y, so we plug in x equals 0. And what we get is something completely wrong. 0 is greater than or equal to 4 is a wrong statement. What does that tell us? We need to shade the opposite side. Remember that one point is enough to decide which side to shade as the solution to this particular inequality. We shade the the right side of the equation with the solid line because it is greater than or equal to. If it were less than or equal to, then we would shade region 2. Now similarly, if I had to graph the line, let me see if I can get rid of this quickly. If I had to graph the line y equals, let's say, 2, and I had to solve the inequality y less than or equal to 2. So let me first graph the line y equals 2. Remember that if there's only one variable, either x or y, it's either a horizontal line or a vertical line. So in this case, y has to be consistently equal to 2. That's the graph of the line. So let's say this is a 2, y is consistently equal to 2. So that's the equation of a horizontal line. Every point on this line, the x is going to vary. The x coordinate varies from negative infinity to positive infinity, but the y coordinate is always going to remain the same. Okay, so that's, let's say, is y equals 2. Now, this line is a solid line because we said we want to figure out y less than or equal to 2. Remember, that's the boundary of the regions, the two regions. So let's see which side we need to shade. Pick the point 0, 0, a convenient point, plug it in. 0 is less than or equal to 2. This is a true statement. 0 is indeed less than 2, which means the area containing, the region containing the 0, 0 needs to be shaded. So it's the region below the horizontal line that we need to shade, and that gives us the solution set. So everything below this region is shaded as the solution. So we just completely shade it, and that green area gives us the solution.